Hey everyone, this is your flip video for March 3rd, 2017. It is on mean absolute deviation, which is called MAD. This is a review from 6th grade. And we're also going to talk about why you need to do this other than just because it's on a test. Okay, let's do a really quick review of what MAD is. It is the way to determine the average difference between the mean and each data point. I'm going to show you a visual that shows MAD in a way that you may never have seen before. It combines a box plot and a dot plot. I don't know if you saw this in 6th grade, but it may make it easier to understand just what in the world you're doing when you are trying to calculate the MAD. So here's an example data set. In this data set, I've created a stem and leaf plot that contains 15 data points, starting from 28 and running through 98. I calculated what we call a 5-number summary. A 5-number summary is what is used to create a box plot. And in it, the median is a 81. The smallest number is a 28. The largest is a 98. The third quartile is 90. And the first quartile is 66. And I have also identified those with circles over here so that you can see. So what I'm about to draw for you here is a combination of a dot plot and a histogram. And in it, what I've done is I first created the box plot showing a scale of 0 through 100 across the bottom. And then I am putting the data points underneath it so that you can see the combination of the line plot and the box plot. The green numbers show where the dot plot data points would go from the stem and leaf plot I showed you on the previous slide. The orange up here is what the box plot looks like using the first quartile, the smallest point, the largest point, the first quartile, the median, and then the third quartile here. The blue numbers that I've shown are the differences between the data point and the average. To calculate the mean absolute deviation, first, you find the average, or the arithmetic mean, of all of the numbers in your data set. Once you've calculated that, you then subtract that number from each data point. Here you can see that my initial mean was 74.7. Then I subtracted 28 minus 74.7 and got a value of negative 46.7. When I subtracted 31 minus 74.7, I got a difference of negative 43.7. I then repeated this process for every green number that I've written on my dot plot combination of the box plot. When I went to find the average at the very end of the blue numbers, which again are the differences between the mean and each data point, I used the absolute value. The reason I use the absolute value is because you cannot have negative distances when you are looking at a difference in data sets. After doing all of that, I calculated that the mean absolute deviation was 16 and 86/100ths. I rounded that to 16 and 9/10. That showed that on average, that kind of sounds silly, but on average, the average was 17 points away from each data point. What that says is that the data in this example was spread all over the place. The smaller the MAD, the more tightly packed all of your data points are. The further apart they are, the more widespread your data is, which is what was evidenced in the example I just showed you. Here's another example. In this one, I'm not going to create a box plot, and I've used 15 data points. I have 5 data points in the 90s, 4 in the 80s, 1 in the 70s, 3 in the 60s, 150, and 149. And I calculated my mean as 79.4. Across the bottom, I've created a dot plot only, and then I subtracted the mean, 79.4, from every data point along the bottom. This example only uses the dot plot and not the box plot. I then averaged all of those red numbers together, again, making sure that I use the absolute value for my negative valued numbers. And I created a MAD that was 12 3/10. This is smaller than the previous one, but it also shows again that my average, or the mean up here, is pretty far away from every data point. See how this data is spread all over the place along the plot. In a small MAD, we would have, and I'm just going to show in brown over here just a random one. What if everything was like this? Let's say you had data points that were all over the place, like that. And when you have one way out there, that would have a much smaller MAD because all of those points were clustered together. Now here's your homework. I want you to create a line plot and find the mean absolute deviation of this data set. There are 5 numbers in the 90s. There are 5 numbers in the 80s, 3 in the 70s, 168, and 159. Be prepared to bring this at the beginning of class tomorrow.